Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So how many of them are here? There will be n of them because I can do the same shit for A2 then and goes on till AN. Right? So I have to do this for n times. So you have n times n minus 1 factorial of them in this case. Now in this case, the second case, say I want to fix okay, let me use a different color here. So I'm talking about the case, the event A2. I'll fix L1. L1 goes to A1. The thing is, I want, sorry. Not A2. I want to fix, say, A1 intersection A2. Because this is how these elements look like, isn't it? In A1 intersection A2. So in A1, L1 goes to A1 and L2 will also have to go to A2. That's what the intersection means. A1 means letter L1 goes to A1. A2 means letter L2 goes to A2. But I don't care about the other elements. How many other elements do I have? I have n minus 2 elements. L3 will have n minus 2 choices. L4 will have n minus 3 choices, and so on. So this will turn out to be n minus 2 factorial. But then this is one of the cases, and I need to sum over all ij's, right? In one particular A1 intersection A2, which is one particular case, I have n minus 2 factorial choices. But then how many of them will I get? I can also have A1 intersection A3, A7 intersection A10, and so on. Right? Not n.
And C2.
I have, exactly, because I can choose A1, A7, these in n choices. But since I is not equals to j, I am restricted to having n minus 1 choices for j. So in that case, I will have n C2 choices, each with n minus 2 factorial of them. Right? So what's the next term? I'll select 3. Yeah. And will go on. So basically what I mean to say is this term will look something like, so if you look, this is, if you simplify, this is n factorial. Right? Okay. So the first term is n factorial minus, the thing is, if you become kind of a bit confident with the sums and stuff, you can directly write the sum. It's something like n factorial minus n plus n c1 You can write it directly. Just for the sake of explaining, I have to take this trouble of the first term is NC1 times n minus 1
N
factorial.
minus 1 factorial.
Yeah. Next minus NC2 n minus 2 factorial plus NC3 n minus 3 factorial. And it will go on. The last term will do something like minus 1 to the power n NCn minus 1 minus 1 to the power n will come. This is the last term anyways. All right. So if you just simplify, this is what n factorial minus. So what does this term look like anyways? Looks like n factorial by I factorial. Right? So I can simply write something like this. Agreed? And it will go on. It will look something like this. Right? Agreed? It's a simplification, nothing else. Let me look at the formula again. So it will look something like the so we call it the nth derangement. So dn represents and letters are not in the correct envelope. This is the value n. You can also write it as dn. This is n factorial 1 minus 1 by 2 factorial plus 1 by 3 factorial. Mm, plus 1 by 4 factorial, and it will go till minus 1 to the power n by n factorial. I mean, just check. I mean, this is how you do it. This is what you get. Interestingly, this is kind of also a proof that this fraction, if you multiply it by n factorial, will always be an integer. Okay. This is what you will get. And interestingly, I still remember there was a question that was asked in one of the interviews. The question was, I don't know what question, where it was. What is the probability that none of the books in the world's largest library, can be any library, are in its correct place, given there is not a single librarian. If there is a librarian, all the books, almost all of the books will be in its correct place. So This was a question, I don't know where, I mean, it was asked to me. Oh, sorry, not me. To one of my friends in one of the reputed interviews. So, any guess? You have the answer in front of you. The approximate answer will be correct to around 300 million digits. So, doesn't matter. So, it is actually that value. I mean, it's simple. Why don't you think? I mean, in how many ways can the books be arranged? It can be arranged among themselves in n factorial ways. And what is the and how many ways none of the books are in its correct place? It's dn, right? But it's the world's largest library or any kind of library. So you can take a limit n tends to infinity. And this is limit n tends to infinity 1 minus 1 by 2 factorial plus blah 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 minus 1 to the power n by n factorial. This is 1 by e, right?